Hi everyone, thank you for joining. So in this video we're going to solve another interesting integer equation. So given that x, y and z are positive integers, we want to find the values for which this equality is satisfied, right? If you'd like to pause the video and try it yourself first, then we will go over it together. Right, so in order to solve this question, I'm sure there are many different methods, but the method I'm going to use requires an inequality. So let's introduce that inequality and convince ourselves that the inequality indeed works. So inequalities, we have p plus q plus r divided by 3 to the power of 3 is always strictly greater than p times q times r, and p, q and r are not only real but positive real numbers, and they are not all equal. Yeah. Okay, so let's think about this inequality. In fact, let's prove that this is true. Right. Let p be m cube, q n cube, and let's say r to be o cube. Right. Okay, now one thing to notice that if we have m minus n squared plus n minus o squared plus o minus m squared, that will give us m squared minus 2mn plus n squared minus 2no plus o squared minus 2om plus m squared, right? And if we simplify it, we will have 2m squared plus 2n squared plus 2o squared, so that goes, that 2 goes and that goes, minus 2mn minus 2no minus 2om, right? Let's put this in brackets, and if we multiply this by, say, m plus n plus o, if we multiply it, and that will give us, we have 2m cubed plus 2m n squared plus 2mo squared minus 2m squared n minus 2mno minus 2m squared o. That's the first one. Plus 2m squared n plus 2n cubed plus 2no squared minus 2mn squared minus 2n squared o minus 2omn. And then lastly we have 2m squared o plus 2n squared o plus 2o cube minus 2mno minus 2no squared minus 2o squared m, right? And notice every term has 2, so if you multiply this by a half, we will get rid of all these 2's here. Okay, let's simplify it then. That will equal to m cube plus n cube plus o cube, so let's highlight the ones that we've already used, so these 3 goes, right? And now what we have here is that we have plus mn squared, which cancels with minus mn squared here. We have plus mo squared, which cancels with o squared m here. We have m squared n here, cancels with minus m squared n there. We have m squared o here, which goes with m squared o there. We have no squared here, which cancels with no squared here. We have n squared o here, which cancels with that. So we're left with minus mno, minus mno, minus mno, so minus 3mno, right? So this long expression boils down to that, right? And notice that this expression here is simply that. Yeah. So if we replace that by that, we will have, I'll write it explicitly here. So we will have 1 over 2 m plus n plus o. That will equal to m cube plus n cube plus o cube minus 3mno, right? Now we said m and o are element of positive real numbers, so that means the first bracket is positive, while the second bracket here is also positive, and we can say m cube plus n cube plus o cube minus 3mno must be greater than 0. Or we can equivalently say m cubed plus n cubed plus o cubed is greater than 3mno. If we divide both sides by 3, we have m cubed plus n cubed plus o cubed divided by 3 is greater than mno. Now, if you notice that, if you remember that we defined mno to p to be m cubed, q to be n cubed, and r to be o cubed. So if we plug this in, on the left hand side we have p plus q plus o divided by 3 is greater than, well, m is cubic root of p, n is cubic root of q, and r is cubic root of o. So instead of m and o, we could write pqr to the power of a third. So that implies we have p plus q plus o over 3 cubed is greater than pqr. Yeah, this is the identity that we want to use. Okay, now going back to the question, we have, this was the initial question that we wanted to solve. Okay, let's rewrite the question. The question was x over y plus y over z plus z over x is equal to 3, where x, y, z are positive integers. Yeah. Since the inequality here we said it was element of positive real numbers, and integers, positive integers are element of positive real numbers, so we can apply this inequality. So we have x over y plus y over z plus z over x divided by 3 cubed must be greater than x over y times y over z times z over x. But notice x over y times y over z times z over x is simply 1, right? Okay, so we have x over y plus y over z plus z over x divided by 3 is greater than 1. Well, if we take the cubic root of both sides, we will have a third there, which is just, again, 1. So in other words, we will have x over y plus y over z plus z over x is greater than, if you multiply both sides by 3. So that is the result we have. But notice we said that, that if x is not equal to y is not equal to z. What if x is equal to y is equal to z, right? Then we will have, indeed, infinitely many solutions. Yeah. Let's have a look at some numerical values. So if x is equal to y, y is equal to z, z is equal to x, and so on. So we have, instead of x over y, we write x over x plus x over x plus x over x. That's just 3. So that solves the initial question, right? So 1 over 1 plus 1 over 1 plus 1 over 1 is just 3. It will solve it, isn't it? Or 2 over 2 plus 2 over 2 plus 2 over 2 is equal to 3. So in other words, x, y, z, we have infinitely many solutions. If x is x, y is x, z is x, or they all y. In other words, if they are equal, that we have infinitely many solutions. But if x is not equal to y is not equal to z, it is impossible. Okay, all right. Well, I hope you enjoyed it. I hope you found it challenging. Thank you very much for joining. I look forward to seeing you in my future videos. Thank you.